Hello guys, this is Atomic Scientist, and today I'm going to be talking about part two of the closed nuclear fuel cycle. We left off at the reactor, and if you haven't watched part one, I highly suggest you go watch part one if you don't know anything about the closed nuclear fuel cycle. I highly recommend you go watch part one. But if you have watched part one, then keep watching if you want to learn part two. So this is part two of the nuclear fuel cycle. Closed nuclear fuel cycle. So we left off the reactor, and if you watched part one, I think you remember that. So the reactor, this is kind of an overview on how a reactor works. The pellets are put in zirconium-coated fuel rods, and then there's a neutron beam in the reactor that scatters the neutrons towards the fuel rods. Some of the uranium in the fuel rods captures the neutrons, splits apart, generates more neutrons and lighter elements. And those elements are still radioactive, but they have much shorter half-lives. Much shorter half-life. There's one element that has a 0.6 second half-life. The longest half-life directly because of that is 13 days. I'm sure you watched the previous video if you're going to be on part 2. So, the reactor, once you have that, there's control rods also. With the reactors and the chance of melting down, you insert the control rods. If you insert all to slow the reactor down, if you insert all of them, the reactor stops. And the control rods are made of boron, which absorbs the neutrons. So there's water. You put the fuel rods in the water. The fission generates huge amounts of heat that turns the water into steam. Then the steam goes up to turbines, which turns the motors in them, and that generates electricity. That's how you get nuclear energy. There's a lot of steam too. So once you're done generating your energy, you're left with spent fuel rods. You can store it temporarily however way, but you should put them in water so they can cool down, and by the time they're cooled enough to handle, they're less radioactive than when you first put them in. So this is the closed fuel cycle. So you have your spent fuel rods, you transport them to a reprocessing facility. They chop the little pellets up into smaller pieces. They put them in acid. They put them in special acids, which dissolves it, and that leaves the uranium floating around, plutonium floating around, and we can extract the uranium and the plutonium that's created from the fission process. So we can extract that and the reprocessing facility sends those bits back to the fuel fabrication facilities, where they can fabricate it into more fuel rods to be used in the reactor, and so on and so forth. So you might be asking, what happens if there's no more uranium or plutonium? Then they go to storage covered in concrete, but there's a lot less waste than if you just did the open fuel cycle. There's so much less waste, which in turn is less radioactive. So yeah. And you can't separate all of it. I'm pretty sure, if I remember right, there's still some uranium-235, very small amounts that's sent back to enrichment to enrich it to get more uranium, and so on and so forth, until you have much less waste. So that's a brief overview of the closed nuclear fuel cycle. This is Atomic Scientist for science, and keep doing those experiments.